A sample of pure water boils at 100 Celsius. This colorless, odorless sample has a density of 1 gram per milliliter. Classify the above properties as quantitative and qualitative. So, which properties of those were quantitative and which properties were qualitative? Quantitative, which have values. So, boiling point of water, 100, it's a quantitative. Also, density of water, which is 1 gram per milliliter, is quantitative, while properties like color, colorless, odorless are qualitative. Calculate the density of a sample that has a mass of 90 gram and volume 30 milliliter and report answer to the correct number of significant figure. You know that density equal mass over volume, so if you have a mass of 90 and you have a volume of 30, you will get the number, okay, 0, 0. This 0 will be cancelled with that 0, so the answer is 3. The small number has 2 significant figures, so you are going to round your answer to 2 significant figures. Don't forget to write the correct unit. Mass, the unit of mass is gram, so this here is gram, because you divide gram by volume, which is milliliter. So it's 3 gram per milliliter. To answer this question, we need to look carefully at the information given in the table. Use the table below to find the mass of sample used and report the correct number of significant figure. You have a mass of empty crucible. Crucible is something like this that we put inside solid particles in order to heat or to weigh. The mass of the empty crucible was 5 gram. We put a sample inside. The mass of the crucible and the sample both together is 12 gram. So the mass of the sample only will be 12 minus 5 equal 7 gram. So you're working, you just say that the mass of sample equals 12 minus 5 equal 7 gram. Carry out the following calculations in A and B and record your answer to the correct number of significant figure using the appropriate units. As we explained before you make the operation, you should make sure that all the numbers given are to the same number of decimal places, then you can do the operation safely. 005, 5, 001, 1, 6, 006, 2 plus 7, 9, 7 plus 2, 9, 3. And then you need to round your answer to the correct number of significant figures. So if we have the smallest number is made of 3 significant figures, you need to round your answer to 3 significant figures. The answer here will be 40. A student measured the density of cube. His observation weighs as follows. It has a mass of 2.7 gram, color is black, volume is 1, texture is smooth. Classify the above observation as quantitative and qualitative. Quantitative could be the mass, just copy 2.7 gram, and volume. Any data which has a value is considered as quantitative measurement, while the ones that are descriptive, they are qualitative ones. So color is black, is qualitative. Also, texture is smooth. This is also qualitative. A student had 2 slices of butter toasted, white bread, and a portion of beans. He looked up nutritional values of the ingredients on the internet. This is what he found. He found that the butter toasted white bread and beans have those values of nutrients, from proteins to carbohydrates to fats and salt. Now, let's start answering questions. Question 1. Give 2 examples of quantitative data. What quantitative data we have here? Any data is quantitative here. So if I say 9.6 protein per gram in beans, use any other value. 1, you have used those. 1 gram fat in bread. These are quantitative values. Give 2 examples of qualitative data. Qualitative data could be the nutrient itself. Okay, if I say beans, butter, bread, these are qualitative data. A student performed an experiment to study the effect of temperature on the amount of solute dissolved in 100-gram water. Results found were as follows. So the student was changing the amount of solute and looking for what's happening in the temperature of water. It should be written in the opposite way, because what affects what here is the effect of temperature on the amount of solute dissolved. This means that the temperature here is the independent variable, and the amount of solutes are the dependent ones. So, of course, the first question will be asked, what are the dependent and the independent variables? The independent variable is the temperature. The dependent variable is the salt amount. Question 2. Describe the relation between both variables. Is it direct or inverse? Looking at the values, here we are increasing the temperature. As the temperature increases, the salt amount dissolved increases. So the relation is direct. The relation, it will be answered like, because as temperature increases, so does the solute amount dissolved or being dissolved. Label X and Y axis to show the results above and describe the slope of each. What we shall write on x-axis should correspond to the independent variable. The independent variable we have here is the temperature, and the dependent variable with the amount of solute. So this will be drawn on y-axis. Describe the slope of the graph. Okay, as the relation is direct, so we are expecting to have a graph like this. Let's answer this question. What is the effect of drinking soda on the heart rate? Here are the number of cans of soda drank per day, 0, 1, 2, 4, and here are the changes that's happening to the heart rate. It's very clear that as the number of cans of soda increases per day, the heart rate also increases. And this means that the relation between them is directly proportional. So the independent variable was number of cans of soda. The dependent variable was the changes in heart rate. A solar farm in California produces much of its output during the summer. when the sun is the most intense. The more sunlight a solar cell receives, the more power it will produce. The more sunlight a solar cell receives, the more power it will produce. This indicates the relationship, which is direct relationship. What is the dependent variable here? So what affects what? The sunlight affects the power produced. So the sunlight, or you can write amount of sunlight, affects the power being produced. Thank you, and I wish you the best of luck tomorrow, inshallah.